All right, this is our last lesson of the year. Not exciting? It'd be more exciting if we didn't do the lesson, wouldn't it? But we have to. All right, so this whole chapter has been about right triangles. Now I'm not going to go through this, but this section right here, well, what I'm not going to go through is showing you why right triangles have anything to do with what we're doing right here, okay? But they actually do. In order to come up with these formulas, I'm not going to show you how they came up with the formulas, and I don't think they did in this book. But you could actually go to like Khan Academy and doubt you'll do this, okay, but you could if you wanted to. He actually shows you how they came up with the law of sines and how they came up with the law of cosines, all right? But right now I'm just going to show you. And you do use right triangles, okay? You use right triangles and trig and all that kind of stuff to come up with that stuff. But what I'm going to do is we are going to take a look. Let me do, tell you what, let me do the example from the book. And I'll just kind of teach how to do this problem with an example. It's probably the best way. Alright, so the triangle looks like this. Now, this is not a right triangle. I don't know, I kind of probably made it look a little more too much like a right triangle. Let's make this not look so much like a right triangle. It's kind of, there we go. That looks a little better, doesn't it? Because what we're going to have to do is we're going to actually solve for some missing angles and sides with a non-right triangle. So if you had a right triangle, you could find, like if you knew two sides of a right triangle, you could always use Pythagorean theorem. If you knew an angle and a side of a right triangle, you could always use a trig function, right? If you had a 30, 60, 90, you could use that, 40, right? So we've learned a lot of different ways to solve for either missing angles or missing sides on a right triangle. But this time, we don't have a right triangle, and we have to solve for some missing stuff. So I'm going to make that angle 97 degrees. Make this little one down here 21 degrees. We'll make this side right here 16. And let's solve for this right here. Okay? What we're going to do first is we're going to do the law of cosines. I'm sorry, I lied. The law of sines. I'm going to use the law of sines with this. And this is when you can use the law of sines. There's a couple different situations. Okay, you can use it when you have a situation on a triangle when you know two angles and a non-included side, or you know an angle, side angle, or if you knew this, side, side, angle. Notice we didn't switch the order of that, right? Okay, so if you have a triangle, now, you know, when you're looking at this, you're thinking, oh no, that reminds me of proofs back in geometry. It's really not proofs, okay? But if you have a triangle that has two angles and a side that's not in between the two angles, you can use a law of sines. If you have two angles with a side in between the two angles, okay, then you can use a law of sines. If you have two sides and an angle that's not included, right, it's not in between those two sides, then you can use the law of sines. So what do we have here? I've got two angles that I know, and then I've got a side. So is it one of these? Which one is it? It's the first one, angle, angle, side, right? Angle, angle, side, because the side's not in between. Now the one we're trying to find is in between, but not the one they give us, okay? So what can we use? We can use the law of sines. Well, here's what the law of sines says. Here's what it looks like. All right? There's actually going to be three of these things, but we're only using two of them. We're going to pair them up. Does this look familiar? Did you do that in Algebra 2? Did you guys do law of sines, law of cosines? You don't remember? Okay. Well, here it is. This is the law of sines. Now, the little a represents one of the sides. Okay. Now, this capital A, now there's a reason why this is A and this is A. Because what do you think the relationship is between this side and this angle? Well, well, right. But I said, right, this is a side and this is an angle. But what's the relationship between that side and that angle? They're what? They're opposite each other, okay? So this A has to be opposite this angle A. Side A has to be opposite angle A, okay? This side B has to be opposite angle B. Now you realize that sometimes they don't even mark the picture with, you know, with the letters, okay? Label them, I should say, you know, with the letters. And sometimes they label it with different letters than A, B, and C, right? These are just real general letters. This represents side C, and this side is opposite angle C. So let's see what we have here. What we're going to do is we're going to pair them up. All right? We've got four things here, right? We got two sides and we have two angles. In order to solve for one of them, we have to know three of those four things. Do we know any of that situation here? First of all, do we know a side opposite an angle in this triangle right here? Which ones? 97 and 16, right. So do you see how they're opposite each other? That's the first thing you want to look for when you do the lost signs. So this could be like the letter A, right, or the lowercase a, and this would be the angle A, uppercase A, all right? And what else do they give us? They give us this angle right here, don't they? Actually, you know what? I'm not going to solve for this side. Let's make this x. Is that all right? Sorry about that. Let's solve for this side right here. So now, so I know these two. So I can plug that stuff into this, right? And now I need a side and I need an angle. But what do I have? I have an angle, don't I? But so what's my if this is angle B, if I want to call it angle B, what's going to be the side B? It's going to be this x. Do you see how they're opposite each other? Does that make sense? So you just look for things that are opposite. You need to know three of those four things. Okay, that fourth one that you don't know is the one that you can solve for. You get it? So really, you're like, well, why do we even need that? Because you have three sides, you got three angles, right? You can combine any of them together. Now, obviously, this angle and this side we can't use. Well, we actually could if we wanted to, because you could find this angle very easily up here, couldn't you? You could do, how would you do that? That's right. Take these two away from 180, you could get this angle, so you could solve for this too if you wanted to, couldn't you? All right? Let's just do that just for fun. 97 and 21, right? So 180 minus 97. The lights go out? Oh, wow, a whole line of them did. That was weird. Last day. Weird things gonna happen. All right, so that's 62 degrees right here. 62 degrees. So we could find y as well, couldn't we? All right, so let's do x first, though, all right, since we talked about that. So how are we going to set this thing up? Let's put the x on the top. So it's going to be x over the sine of what? The angle opposite x. What's the angle opposite side x? 21 degrees. Equals what? B over sine of b. So do I know one of my other sides? Yep, 16. And over the sine of the angle that's opposite 16, which is 97. You've set it up, and now you can solve for x. Watch how easy it is to solve for x. You could cross multiply, but x is already on the top. I did that on purpose, okay? Watch the video from the honors geometry class, and I talk a little bit more about this, okay? But for now, we're just a little strapped on time. So what I can do is, if I want to get x by itself, what is the sine of 21 doing to that x? It's dividing, isn't it? So, and this is what you wanted to say, how do you get rid of something that's dividing? You multiply. So you multiply both sides by what? Sine of 21. Remember, the sine of 21 is just a number, isn't it? It's just a decimal number that I would put in my calculator. So now I've got x by itself, and now I can just chuck that into a calculator. See how easy that was? The math was pretty simple, wasn't it? Just had to multiply by the sine of 21. Right? You had to set it up right. But then to get x by itself, you multiply by sine of 21, chuck it in a calculator, bang, you're done. Pretty cool, huh? So that's a nice, easy way to solve for a missing side if you don't even have a right triangle. So let's do that. It's 16 sine of 21, sine of 21. I always like to close that parentheses, I don't know why, just do. Divided by the sine of 97, sine of 97. All right, and there it is, 35 point, let's round it to one decimal, so 0.3, is that right? 35.3. So that's what that is right there, 35.3. Let's solve for y. What's that? You're right, it doesn't make sense. What did we do wrong? We did something wrong. I think I know what it is. You're absolutely right, Alex. I'm glad you said that. Because there's no way, because look, that's the biggest angle. That needs to be the biggest side. This is the smallest angle, so there's no way that's going to be bigger than 16. So, what do you think I did wrong? I set it up right. I set it up right. But what do you think I did wrong here? My guess is, yep, you know it. It's in radians. Exactly right. So if you use this calculator, you got to make sure. And I thought I made this in radians before, but hit enter. Now let's give it a shot. Okay. Watch, I'm going to put the same exact thing in here. I'm going to get a different answer. I'll keep this one up here just to show you. Because this was in radians, I have to have it in degrees. All right, so I did the math right. It's just the calculator. And Alex, I'm glad you brought that up because I would have just kept it there and wouldn't even think about it. Sine of 97. Look, it's exactly the same, isn't it? But when I hit enter, look what I get. Now, does that answer make a little more sense? Yeah, we'll say 5.8. Is that right? Yours probably already defaults to degrees. Yeah. Like if you had a regular scientific calculator, you would hit 16, you would hit times 21 sine. You don't hit sine first. Let me see your calculator. Hold it up to me. Nope, you would do it exactly this way. It's a scientific calculator, but it's got the two rows, right? If you see it like that, then you do it exactly the way this calculator. They call it direct algebraic logic. One calculator called it that. So I think all three of you have a calculator. You would do it just like this, okay? And that makes sense, doesn't it? Because if that's 16, that's going to be considerably smaller than 16 because 21 degrees is considerably smaller than 97 degrees, isn't it? All right, so yeah, that definitely makes sense. Let's do, I'll tell you what, let's do another example with the law of sines. Let's do one where we actually find a missing angle, right, instead of a missing side. Let's do it a little quicker, though. Again, this is a non-right triangle. And that's what you use the law of sines and law of cosines for. This is 45 degrees. This is x degrees. And this is 8. Now, what do we have here? Oh, I got to do one more thing. That's a 10. I have, what, two sides and an angle, right? And the angle is not in between the two sides. So what is this? This is side-side angle. And what do we use for side-side angle? Law of sines, okay? So let's do this real quick. I always look for the opposites, right? I see these two are opposite, and I see these two are opposite. Now remember how I put like A over the sine of A, B over the sine of B? I could actually switch that if I wanted to, as long as I do that for everything. I could put the sine of A over side A. You follow me? Or the sine of B over little b. And why would I do that? Well, I would do it when whatever I'm trying to solve for, that's what I'm going to put on the top. It makes my algebra a lot easier. So on this one, I'm not going to put 10 over the sine of x. Now you could, it would work, but this is a little easier. So what I'm going to do is I'm going to go the sine of x over what? What's opposite? 10 equals, now if I put the angle on top, I got to put the angle on top with these two. So what am I going to write this as? The sine of what? 45 over what? 8. Good. Now watch what I'm going to do. Watch the algebra. The first part is pretty much the same as what we did before. I have to get rid of the 10. It's being divided, so I multiply by 10. I'm going to put the 10 out in front. That's how we usually write it. But this is the sine of x equals all this stuff. How do I get rid of the sine? I want the x to stay there. How do I get rid of the sine? Take the inverse of the sine. So that's not new, is it? We did that before when we did our trig functions. So you take the inverse of all this stuff. And then you just plug that in your calculator. That's really not much more difficult, is it? It's one extra little step, okay, but it's really not that big of a deal because you've seen it before, which is nice. Plug that in a calculator and you should be good to go. Let's do that real quick, then we'll go to the law of cosines. I like to put the stuff in here first and then hit the inverse sine. It just seems, it doesn't matter, but I think you're less likely to make a mistake if you do it this way. All right, so I'm going to go 10 sine of 45 divided by 8. All right, and I got that answer. Now, how do I take the inverse sine of that without re-punching it in? I just hit second function sine of what? Of my answer, right? You follow me on that? And so the answer is that 0.8838 number. And there you go, 62 degrees. right? And that's what that is. Does that make sense that this could be 62 degrees? It is, because look, 45 is opposite the 8, right? And then this is 10, which is, this side's a little bit bigger, so the angle's got to be a little bit bigger. And 62 is a little bit bigger than 45, so yeah, it definitely makes sense. So make sure you know how to do that on your calculator, right? I got like 7 or 8 minutes left, so let's do law of cosines. I think we can do law of cosines in that amount of time. Got all that written down? Now on yours, Leslie, it might. Do you have an answer button? I don't know if you have that answer button on there, so you might have to hit inverse sign first. Put a parentheses, or it probably already gives you a parenthesis. Did you get it? Okay. So you do the inverse sign first, and then you plug the stuff in. So it should be good. Hello.
Excuse me. These are the people the only ones that I know that I'm going to be proctoring finals that I would need to get from you. And I forgot to look up what period he is. And I know
He's
sometimes.
third.
Okay. I do other people's, so they haven't talked to me.
Right.
But those are the two that I know I need.
Okay. All right.
Thank you.
The first one's not till Tuesday, so hopefully Monday I'll have. Is that all right? Okay. All right. Let's see. Law of cosines, right? Let me draw the triangle, then we'll write down the law of cosines. Now again, use law of cosines with a non-right triangle. Alright, so this is law of cosines. And when do we use the law of cosines? We learned when to use the law of sines. When do we use the law of cosines? When you have side, side, side. So if I know all three sides, I can use the law of cosines. Okay, and when you also have side, angle, side. When the angle's in between the two sides, then you can use law of cosines. Alright, so in those two situations, that's when you're going to use the law of cosines. So let's put some numbers in here, then I'll show you what the equation, or what the formula says. And that's it. Oh, no, need another one. So what situation do we have here? We got side, angle, side, don't we? Okay, side, angle, side. So I'm going to use the law of cosines. Well, you don't even know what the law of cosines is, do you? So it starts off with something that looks familiar to you. It looks like the Pythagorean theorem. So we're not going to go a squared plus b squared equals c squared. I'm going to reverse it. I'm going to go c squared equals a squared plus b squared. So you know that part already, right? But it doesn't stop there. You got a little bit more. It's minus 2ab cosine of angle C. Alright, so that right there is the new part. That's not really that much, right? Minus 2ab cosine C. Alright? You know what I might do? I'm doing this for my geometry class. I have a little formula sheet that I'm giving out. So I'll give that to you as well. And it's got the law of cosines written down. Since you're only learning it one day and then taking a test on it, I'll give you the formulas, alright? But you just need to know how to use them. Is that alright? Okay. And it's got like the trig stuff on there too. It even has like 45, 45, 90, 30, 60, 90 stuff, you know. It'll have some other things that you don't have to worry about, you know, because they needed it in their class, but it's got a lot of that trig stuff, so that'll help you out since, you know, we've just been going over this very quickly. So what does this mean? This is little c, and this is angle C. So that means that this side has to be what to this side? It's got to be opposite this angle, right? So this side is opposite this angle. Well, look, they only give you one angle, don't they? So what do you? So this would be my angle C. What would my side C be equal to? It'd be x. What do you think the A and the B are on this triangle? The 9 and the 11. So basically, it's just plug and chug, right? Just plug everything in. Pretty simple, isn't it? If you know the formula and you know what all these numbers represent in relationship to this formula, you should be good. So what is that little c again? That's our x in this case, isn't it? But it's x squared equals a squared plus b squared. That's the other two sides. It doesn't matter what order you put them in. Let's go 9 squared plus 11 squared minus a 2. And then AB. Well, this is my A and my B, so I'll put 9 and 11 right there. And then it's cosine of angle C, which is the angle that's opposite this side right here, which is 28 degrees. Now, the hardest part about doing this problem is using your calculator. All right, so you got to practice. Now, I really, really suggest that you go watch the honors geometry video from this lesson, because I go into a little bit more detail and take a little bit more time on this, but we're just rushed on time here. What I would do is I'd put my own parentheses. Do you see where I put those red brackets right there? I would put my own parentheses in there. So what I'm going to do, watch what I do quickly. 9 squared plus 11 squared minus, now watch what I do. See that red right there? What do I put? I put a parentheses. I think it's important to do that. So it's 2 times 9 times 11, and then just hit the cosine button and then hit 28. Now watch. See how that 28 has its own little parentheses? I close that one, but I also have to close this one right here, don't I? So I need to put a second one. You with me on that? So if I hit equals, I get that. Now that's not my answer though, because x squared is equal to this. What do I do with that number? Square root it, right? So square root my what? Answer. You got it? And then that's it right there, 5.2. So x is 5.2. You should have a square button on there. You should just have an x squared button. Alex, look at our calculator, see if you can find it. Okay. All right, so practice that. I'm only going to do that once. It's on the video, okay? Go back and look at the geometry also. We're going to run out of time. There's no way I can do this. Now, there's also another type of problem where it's side, 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 and you have to find the angle. All right? So, for instance, if it was like 5.2 squared equals 9 squared plus 11 squared minus 2 times 9 times 11 cosine. Let's pretend we didn't know that was 28. Let's say we knew this was 5.2. We didn't know this was 28. So what would I call this? Call it X or C or whatever. It doesn't matter what letter. Now, how would you get that by itself? Let me just do this real quick, okay? Just give me a second. Watch. What I'm going to do, I want to get that by itself. So what do I get rid of? Get rid of the 9 squared and the 11 squared. How do I get rid of this 9 squared and 11 squared? Minus it. That's right. So I minus it. So I do that to both sides, right? Everybody see that? Now watch. It really isn't that hard. What's this negative 2, 9, and 11 doing to this cosine of C? It's multiplying. How do I get rid of it then? I divide. So I divide. See how easy that is? What's that all equal to? The cosine of C. But how do I get C by itself? I have to do what to it? I got to take the inverse cosine, and then that's how I can solve for that angle. You won't get exactly 28, but because we rounded that to 5.2, but it should be really close to 28. All right? Yep, let me give you, hate to do this, but let me give you a worksheet. You know what I'll do? I'll give you the worksheet. If you want to do it, you can do it. If you don't, you don't have to. I'll still give you the 5 points for it, okay? But it is good practice, and you may want to do that. Yeah. What is that one? That's yeah. That's the trig one. 284s, right? Okay. Yep.